been recording. I've not been recording, and thank you, Linda, for reminding me. I am so bad about that. I swear I'm going to remember more. Thank you, Linda.
You're welcome.
Yeah, you got it, Linda. And so remember I talked about the plastic? I said one band of plastic, but they're really two. Those pieces of plastic, as the nails are blown, but when they come up to where they're going to get shot out of the gun, and that piston drives that nail, this plastic flies. So I've had it hit me in the face more than once. And a skips panel, SC, not SK, SCIP versus an SIP or SIP panel. SIP is structural insulated panel, which you see on the book there. I'll go back to the book and point it out. That's got plywood on one side, and depending upon the panel itself, X amount of thickness of foam insulation, rigid foam insulation, and then something on the other side, usually plywood or CDX, which is a kind of plywood. Skips panels are structural concrete insulated panels. And my friend Peter's house was built out of skips panels. Those panels were 5 inches of rigid foam, is the middle of them, on either side, and tied together through the foam is 6, 6, 10, 10. That's 6, 6, 10, 10 welded steel wire, which is a lath for concrete, and then 1.5 inches minimum of gunite or concrete is blown onto both sides of that wall, basically making a 8-inch thick wall. And in Peter's case, it was battered, which means the wall was wider at the base, which he accomplished that by slumping some of his gunite when he was putting it on, when he was having it put on. And then he did it with his veneer, because he veneered all his walls with a stack stone veneer. Anyway, that's skips panels. I told you I'd get back to you about that. Let's remove my pen, get to gallery view, go to share screen, go back to the textbook. Let's get through this textbook. I'll go ahead and read this one. House design and planning. As mentioned earlier, the entire team, owner, architect, general contractor, and subcontractors is involved in the design and planning for a green home. The architect's preliminary house plans are reviewed by those who will build the home. Now, stopping again, most owners don't do projects like this. They don't do projects like this because they're more concerned with cost than anything else. And if you're more concerned with cost than anything else, you have not chosen your contractors at this point. You're putting it out to bid to various contractors at this initial design phase. You don't know who you're going to do. So I always encourage people, owners, to choose your contractor the way you would choose your doctor or your dentist. Get recommendations, get a feeling, meet the person, talk to people, get a feel for them, and then choose the person that you're going to have work, pull your teeth or work on your insides, just like you would a doctor. Choose a contractor, because these people are super important to your whole life, and you want to be able to work with them, and the relationship is just as important as the finished product. I guarantee you, if you have a good relationship, you should get a good product. That's my philosophy anyway. The architect's preliminary house plans are reviewed by those who will build the home, each looking for ways to improve energy and water efficiency, make the house more durable, simplify utility system installation, and make the house more comfortable. There are often group meetings where the designer, owner, contractor, and key tradespeople discuss the house plans, examine the impact of each recommendation, and how the work will be carried out. The general contractor and trade contractors can also recommend green building materials and equipment that best suit the project. A building project that is planned by all who will work on it is generally easier to manage because everyone is familiar with the design, the green goals with each other, with the design, the green goals, and with each other. Costs are also controlled better than for a traditionally built home because the building team has already worked out how the details of each trade will affect the others. Boy, it sure sounds good, doesn't it? This eliminates the need to buy additional supplies that were not part of the original budget plan. Good luck on that one. Okay, resource efficiency, which is one of my topics. Let's see. Kevin, did you ever show up? Kevin Nolasco? Manny Gutierrez, did you show up? Manny? Josh Santana, did you show up?
I'm here, Rodney.
Josh, cool, made it. Hey, Josh, will you read along for us, please? Resource efficiency, read that.
Yeah.
Okay.
Green home construction uses resources very efficiently, causing as little impact on the environment as possible. Efficient use of natural resources can result in more functional products. For example, engineered lumber makes use of nearly the entire tree and produces far less waste than sawing conventional lumber. Engineered lumber can also be longer, stiffer, and more dimensionally stable than sawn lumber.
Yes.
The designer and the contractor should consider the following when choosing materials for a green building. Let me scroll down. Energy savings, insulation, photovoltaic panels, and Energy Star certified water heater are all considered green because they conserve energy. Product longevity. Durable products need to be replaced less often than poorly built ones. This means that resources and energy used to make longer lasting products have less impact on the environment. Indoor air quality.
Yeah, let's see if there's anything above. Okay, keep going. Indoor air quality. Thank you.
Sorry. The most common causes of poor indoor air quality are paints and carpeting that have high volatile organic compounds, heating and ventilation devices that circulate stagnant or foul air, and lack of ventilation causing excessive stale air buildup. Production location. Products and materials harvested, mined, or manufactured relatively close to the job site require less energy to transport.
Okay, so which would be great if we could do that, get stuff that like drywall is not manufactured too close to this place. We don't have any timber making operations anywhere around here other than local wood, like Robbie Bjorklund's place where he slabs local trees to make tables and things like that. Insulation is not made too close to here. It's made in California. We have plants that make it in California. There isn't a whole lot other than electronics perhaps, and smart home systems that might be made out here in some of our high-tech places in Goleta, but there isn't a whole lot. So that it's not really that germane for us. It doesn't mean a whole lot for us. Sourcing materials that are manufactured relatively close to the job site, except, here's one for you, a fair amount of stone work happens. And natural sandstone does occur around here. So that's a very green thing to use because it does occur around here and doesn't have to be transported long ways. And there isn't a lot of environmental impact on that particular resource. Gravel is another one. Gravel's mined not too far. There are gravel pits in Buellton and not that far from us. If you're using gravel, that's also a resource that can be accessed relatively close to us. But let's look at this, what I couldn't remember what VOC stands for. It stands for high volatile organic compounds. And now we're always looking for low VOC because high VOC, high volatile organic compounds off gas. And there are carpets that are notorious bad off gassers of really bad stuff, organic compounds that off gas. Carpets, mastics, paints, a lot of VOCs and paints where even after they're applied and they dry, they're still off gassing for months later. Particle boards, there was a lot of controversy around mobile homes because so much particle board was used, and the glues, the formaldehyde present in the glues to bond the wood chips together to make the particle board was super high VOC, and it kept off gassing, and people were actually getting sick. And you definitely want to ventilate the foul air, which kind of means your bathrooms need fans. Now, by code, if your bathroom has a window, you've satisfied the code requirements. If your bathroom has a window, then you've satisfied the requirement for venting your bathroom air out for air changes. But put in a vent fan. Windows are great, and the odors and things will go out that way. Moisture will go out that way from your shower, but put in a vent fan. Tell that vapor, the foul air and the moisture vapors, tell it to go away and tell it right where to go. And don't be equivocal about it. The moisture is not good for a house ever. Moist air and foul odors are not good for your nose. So Josh, why don't you go ahead? You're doing great. Read the rest of this for us, starting with resource consumption. You there, Josh?
Sorry, I muted myself. Resource consumption during production. Many manufacturers have made their production processes more energy and water efficient by using less energy and water during production. The products have a smaller impact on the environment. Green products are also chosen from recyclability. From their recyclability.
Yeah.
Is the product made from recycled material? Can the material be recycled in the future when it is removed from the house? Perhaps during a remodel, or will it end up as a waste in a landfill? Many common materials used in construction, wood, steel, some plastics, can easily be recycled into new materials and therefore have less impact on the environment. These products have a lower environmental impact because their raw materials would have been disposed of as waste had they not been reused.
Pretty simple. Okay, recycled products and products that can be recycled is really good. Now, here's the really good news. I'm jumping a little bit ahead, but the really good news about us in Santa Barbara is that we are required to recycle construction waste. We're required to recycle waste, period. To, I think it's 80% or 70%, or I can't remember the exact amount, but Marburg exceeds all the standards that we need for recyclability. So when our stuff goes to Marburg, whether it's a mixed bunch of trash or whether it's separated out clean concrete, separated out clean green waste, that is landscape stuff, or clean wood waste that's just wood and not metal, or clean metal waste. That's all stuff that we can do, and Marburg recycles all of that stuff, including clothing. I talked to a guy in Marburg yesterday. I took out a microwave that gave up the ghost, which really bugs me. I love that microwave, but I took it to their e-waste facility so they could recycle it in their e-waste. Talked to the guy a little bit. My wife actually talked to him about clothing. About, do you guys do anything about, when you get people throw away clothes, right? Do you guys recycle those? Well, yes, they actually do. They save those clothes until they get enough of them, and then they ship them to countries that need them, like someplace in sub-Saharan Africa or places where people can use, recycled clothing. So Marburg takes virtually all of your trash and recycles it, goes through it, picks through it, takes the stuff that can be recycled, sorts it, puts the stuff that can't be recycled into the landfill, and gets the products that can be recycled to the places they need to go to be recycled. So that's pretty impressive. And it's a good thing for us that they do it and they absolve us of having to do it. Now, they don't do it for free. Marburg is one of the higher costs of trash handling around. They're almost twice what Ventura is per ton. But it's that the reason for that is because it costs them to do our recycling for us, and they do it to sort through. So here's for Marburg, A plus company in every way. I got nothing bad to say about Marburg ever. Nothing but good stuff. So energy efficiency, let's get.
Excuse me, Rodney, twice as much as what? Twice as much as what?
Ventura.
Oh, okay, thank you.
Yeah, so Ventura is starts
A
with,
lot cheaper.
what's it called?
It's a lot cheaper over here.
Yeah, a lot cheaper. And it's what's it, Harrison, right? Harrison's the big guy. Yeah, it's just
Yeah.
cheaper by the ton because they don't have those facilities where they sort. So we pay a lot more, but we get, we and us as humans, get the benefit of that paying more. So I believe it's absolutely worth it. Okay, so let's get a volunteer to read. Let's get who wants to read? Who wants to read energy efficiency?
Right, I'll read it.
Okay, thanks.
Energy efficiency. Energy consumption has far-reaching environmental impacts, from the mining of fossil fuels to the environmental emissions that come from burning non-renewable energy sources. A home consumes energy month after month and year after year, so the impacts of energy use build up over time. For this reason, green home programs place great emphasis on energy efficiency. Energy is consumed not only during the operation of a home, but it is consumed as the house is built, as the raw materials are mined or harvested, and as the building materials are transported to the site.
Keep going.
About 21% of energy consumed in the United States is used in homes. At one time, most of the energy went to heating the home, but in the recent years, a greater percentage of energy consumption has been by appliances than by heating homes. Homes have gotten larger, but due to the focus on insulation and weather tightness, less energy is needed to heat larger homes. At the same time, the average size of a refrigerator has increased dramatically. More larger televisions are in use. An increasing number of homes have clothes dryers and dishwashers, and the list goes on. The goal of green construction is to allow for these
Conveniences.
conveniences while reducing the amount of energy the home consumes. Some green homes use renewable energy sources such as solar heating and photovoltaic and wind-powered generators. These homes produce a portion of or even all the energy they need to operate.
Sorry, didn't mean to do that. Okay, there you go. Keep going.
There are several ways a green home is made more energy efficient than an ordinary home. The appliances and lighting selected are the most energy efficient available. The energy using products in a green home most often have Energy Star labeled in figure 27.9, indicating that it has been tested and proven to be energy efficient. Energy Star is a program that was developed by the U.S. Environmental Protection Agency, EPA, and the U.S. Department of Energy, and is now in many countries throughout the world. Devices carrying the Energy Star service label, such as computer products, office equipment, kitchen appliances, and water heaters, generally use 20 to 30% less energy than standard models. A green home is designed and built in a manner to maximize the insulation in the floor, walls, and ceiling. It also built to be as airtight as possible, reducing energy loss due to air leaks. The windows and doors are selected for energy efficient glazing and excellent air seals.
Okay. Excellent. Thank you so much. So yeah, Energy Star. Look for the Energy Star mark. Almost all your water heaters have got it on there, and your forced air units. Weather resistance, water conservation. Let's see how far we got to go here. This is the radon gas. This is craft supplies, VOC. There's some education, green cert. Okay. Okay. So I want to stop for a minute and tell you about a few things. Okay. How did I get? How did I get that? How did I get that? How did I get that thing to get so big? That wasn't it, was it? Nope. This is weird. I don't know how I got it to do this, but we'll see. How did I get it so big? Okay, that's probably how. All right. I wanted to show you, I want to go back in here. The week 15, which is the week we're in. Okay, we've been going through chapter 27, but let's just take a look at a little video on indoor air quality.
Today, builders meet ASHRAE requirements for whole house ventilation. Meet ASHRAE requirements for whole house ventilation using different design approaches. In a standard supply-only solution, the thermostat calls for heating or cooling. The controller opens the damper of the supply duct attached to the HVAC air handler unit. The supply damper opens and negative pressure in the return plenum brings in fresh air from outside. Fresh air is then circulated throughout the home when the controller turns the central fan on. An exhaust-only solution is the least expensive design for meeting whole house ventilation requirements. Stale air is exhausted through a Whisper Green Select ventilation fan, the best performing, most energy efficient ventilation fan available. Fresh air is brought in through leaks in the building envelope. Introducing the Select Cycler System, brought to you by Panasonic. Select Cycler System is a low-cost whole house ventilation solution that provides the lowest impact to HERS by combining the best parts of central fan integrated ventilation with the Select Cycler. Panasonic is able to provide builders the ultimate energy efficient solution with the lowest cost per HERS point for supply or balance systems meeting ASHRAE 62.2. The Select Cycler System was designed exclusively to work with Whisper Green Select fans, which incorporate pick-a-flow adjustable CFM technology for optimal use in balanced mode. The Select Cycler System has two modes of operation. During balanced mode, the thermostat calls for heating or cooling. The Select Cycler controller opens the supply damper and activates the Whisper Green Select at the same time as it starts counting time or flow. The Fan Connect switch operates Whisper Green Select and adds time to the ventilation requirements. If you overventilate from too much fan operation, the Fan Connect switch counts towards the next hour. If the heating or cooling cycle is too short to meet ventilation needs, the Select Cycler controller will also activate the HVAC air handler unit. While in balanced mode, Select Cycler becomes the lowest cost per HERS point solution for balanced ventilation. During hybrid mode, the thermostat calls for heating or cooling as needed. The Select Cycler controller opens the supply damper to provide fresh air, and the controller starts counting time or flow. If normal heating and cooling cycles don't run long enough to meet required ventilation, the controller will also power on the Whisper Green Select ventilation fan via the Fan Connect switch to provide supplemental ventilation. In hybrid mode, Select Cycler is the lowest cost per HERS point solution for supply ventilation. The Select Cycler system offers optional accessories, including the Temp Guard hot and cold temperature sensors for ventilating in extreme climates. So how does it work with the system? The thermostat calls for heating or cooling. The Select Cycler controller opens the fresh air damper to meet ASHRAE ventilation requirements and starts counting time or flow. The hot Temp Guard sensor detects the outdoor temperature. If the outdoor temperature reaches 91 degrees Fahrenheit, the sensor will override the damper to remain shut. The cold Temp Guard sensor detects cold outdoor temperatures. If the outdoor temperature drops below 37 degrees Fahrenheit, the sensor will override the damper to remain shut. The range hood pressure relief control switch helps solve depressurization issues in the home. When the range hood comes on, negative pressure builds in the house and air is pulled in from leaks in the building envelope. The range relief pressure switch senses the range hood operation and opens the damper.
Wow.
Rely on the Panasonic Select Cycler system to be your low-cost whole.
Wow. Does anybody have any thing they want to add to that or ask about that or comment on that? Whole house systems are now required.
I have a question on that. So where I live, I have an upstairs, and then the thermostat is like on the lower level.
Yep.
So when I turn on the heat, upstairs is like 120 and downstairs is 75.
Yeah.
Wouldn't it be wise to put like a thermostat up in the higher rooms? That way it reads the temperature up there and keeps the stuff all adjusted instead of 120.
I agree. So the problem that you're talking about is a problem that a lot of people experience and that is the zoning of houses, where parts of the house are cold or hot, right? Where it's not, in a two-story house, if your thermostat's on the lower level, then yes, as it heats up, it's going to be hotter upstairs. One solution besides, you can ask an HVAC guy about a solution to that, and he can put zone dampers, right? So you can shut some of your supply air and open some of your supply air and try to zone your heating and cooling systems. Another way you could do it is you could get a wireless thermostat. That's what I have. So with a wireless thermostat, it's not in one place. You could take your wireless thermostat and take it upstairs and let the upstairs ambient temperature govern what your thermostat does rather than downstairs. Chances are will be warm upstairs and cool downstairs. You're going to have,
Yeah.
Balancing heat and cold in houses is a problem, especially because of the second law of thermodynamics, which is
hot air rises, right?
heat seeks cold, exactly. Or hot air rises, same thing. Heat seeks cold. The second law of thermodynamics. So it's a problem that a lot of people have. So you need to zone your house somehow and check out a wireless thermostat. Mine works really great. I really love it.
Yeah, I'm gonna check into that.
In whole house air conditioning now, I know that video was relatively complex. It was for me, so I suspect it was for you. There were some things I didn't understand, like some of the acronyms, the letters that stand for things. I didn't know. I do know what HERS means, but I can't tell you what it is off the top of my head. But here's what I know is that the city and county building departments in our area are now requiring for new construction whole house ventilation systems, just like they showed you, where there's a controller that opens up an outside air vent and draws in outside air and circulates it throughout the house. Now, they are buying and letting slide, like for the house we're doing, whole house air ventilation by basically the leaks. so that when you turn on the hood fan, or when you turn on either of the bathroom fans, which are Panasonic Whisper Quiet fans, they draw air, right? They draw air from the room they're in, but they draw air from all over the house and exhaust it. So that means that when there's a negative pressure drawing air, it's pulling air from any leaks outside. So you are getting fresh or makeup air from outside the house through windows, through doors, under doors, through vents, through attic vents. It's a natural process that's going to occur when you turn on a vent fan. And they're letting that slide in a lot of houses. Bigger houses and brand new houses, they're requiring dedicated fresh air systems to bring in fresh air into your house, circulate it, and then exhaust it. So they want air changes. And that's what CFI means, cubic, let's see. Cubic.
That's CFM, isn't it?
It's CFM, yeah. CFM, not CFI. CFM, which is, what does it stand for? My memory is gone, man. It's gone. Let's see.
I know the M's for minutes. Something.
CFM. Cubic feet per minute, duh. So CFM is about cubic feet per minute. So, and that's air exchange. So fans are rated with CFM, and that's how many cubic feet per minute they can draw out of the room. So you take the cubic feet of the room, take the CFM of the fan, and that will tell you how long it takes to do a complete air change. That is, change all the air in the room, draw it out, and then it's replaced by other airs that comes into the room. So air handling is big, just in terms of just a healthy indoor air quality house. You don't want a house too tight. You want air to circulate, and you want the bad stuff to go out. And a perfect example of that is this pandemic we're all experiencing, and social distancing and air circulation. You know, they're letting us be 6 feet away from each other. So you can conceivably be 6 feet away from a COVID infected person and not get COVID because you've got enough air moving around to blow those germs and microbes and viruses away, and you're not sucking them in. So it's the same concept. Healthy air is to keep it moving so all the bad stuff goes out, moves. We want air. We don't want stagnant air. That's what indoor air quality is about. And okay, where are we going to go now? We're going to go. Let's see what we got here. Let's look at energy efficiency. Let's see what I got here. Okay, I got a couple things on energy efficiency.
We all want a comfortable home, warm in winter and cool in summer. And especially these days where most of us are keeping a keen eye on our
Wait, is he talking about shrimp on the barbie?
electricity and gas bills. We're about to find out 5 key elements that will help you create a comfortable, energy efficient home and help you save on your energy bills. Firstly, we need to work out the orientation of our home and what we can do to maximise the warmth of the sun in winter and minimise it in summer. The sun's path changes according to the seasons. It's higher in the sky in summer and spends a lot of time shining on your east-facing windows in the morning and west-facing windows in the afternoon. In winter, it's lower.
Okay, so that's not correct for where we are. He's obviously below the equator in Australia or someplace like that. And in our case, it's south-facing. South-facing is what we are concerned with. South-facing.
The sky will shine through north-facing windows. Once we understand how that all affects our house, we can take steps to make it work for us. For new homes, aim to have your main living areas facing north where possible to take advantage of the sun's path, and place bedrooms or wet areas like bathrooms and laundries.
So substitute north for south.
To the south or west. For established homes, you may be able to change the way you use existing rooms. For example, turning a north-facing bedroom into a general living area. If you're building or renovating, consider installing larger windows in your north-facing rooms. They'll let in plenty of winter sun and they're easy to shade during the summer months. Eaves, pergolas, or adjustable horizontal.
Okay, so remember, you can't just willy-nilly add a bunch of glass to your house. You, if you're going to do it legally and conform to local building codes, you need to do things like have energy calcs made by someone that's versed in Title 24. And I'm going to show you some of the stuff on the plan that's required that we're doing as soon as we see this video. And you'll see some of the stuff that we're required to do right now to have everything to do with green building and just what he's talking about.
Horizontal shading will provide effective protection for north-facing windows in summer. These will also allow the low-angled winter sun to enter your home in the cooler months. Minimise the size of windows facing east, west and south, and make sure your east and west facing windows have effective vertical shading for summer. In winter, having thick, well-fitted curtains and pelmets will help to keep your rooms comfortably warm. And double glazing windows is a great way to keep the heat in and reduce external noise.
And you cannot put in a window today in Santa Barbara that is not either dual glazed or laminated. It's got to have an R value greater than a single pane of glass. And the only way you can put in glass in a window in a house that's not dual insulated is if it's a landmarked or a historic building where they would only go for one type of glass, and they won't, you can't put in newfangled stuff.
Insulation is one of the most important ways to make your home energy efficient. And a well-insulated home could save you up to a staggering 45% on your energy bills. The most important thing to consider with insulation is the R value, a measure of the material's resistance to heat flow. The higher the R value, the greater the insulating effect and the bigger the savings. The ceiling is the most important area to insulate. In Victoria, a minimum of R3.5 should be installed, but if you have the space, you can install up to R5. Walls and floors are harder to insulate in established homes, but if you're building or renovating, don't forget to include these areas. Having windows placed across from each other wherever possible means you'll get good cross ventilation when those cooling breezes roll in at night or when a cool change hits. Think about draft proofing your house for the winter months. Cracks or gaps around doors or window frames let the cold air in and the warmth out. There are a number of sealants and strips available that'll help you draft proof quickly and easily. Making smart choices when buying heating or cooling appliances, water heaters or other everyday appliances like your fridge will set you up for comfort and manageable energy bills. Always check the energy rating label on new appliances. More stars means greater efficiency and lower running costs. Lighting is one of the bigger areas of electricity usage, so you can make savings here as well. Offer more efficient fittings such as LED or fluorescent globes. And avoid downlights if at all possible. They have to be installed in large numbers to get even lighting, which of course increases your power consumption. If you're building or renovating, make sure you think about your lighting plan and opt for pendant lights over multiple downlights. So here's a recap of the best ways to make your home more energy efficient. Have larger windows and your main living areas facing north. Install shading that keeps the summer sun out but lets the winter sun in. Make sure your home is well insulated and well draft proofed. And opt for energy efficient lighting and appliances. If you want more information on how to make your home more energy efficient, head to our website.
back with WSJ Lunch Break. I'm Wendy Bounds. How does Bill Nye, the science guy, keep his home humming with little energy consumption? Well, we're going to ask him right now. Bill Nye, who's joining us right now from Los Angeles. Hi there, Bill.
Good afternoon.
I'm so happy to see you and your bow tie. I would hope you'd be wearing nothing less with us. Tell us a little bit about this home of yours in Southern California. About how big is it? How old is it? And then we're going to drill down to sort of the nitty gritty of the technology there.
The house was built, in my understanding, in 1951. It's a Mountain home, which was some guy who competed with the birds. We're architects who designed these buildings that you might have heard of in Pasadena, where they're very distinctive craftsman style house. This one is somewhat more modest than those, but it's about, the house itself is about 1,200 square feet. That's it.
All right, 1,200 square feet, and you've done a lot to sort of retrofit it to be very energy efficient. A lot of people think you often have to start from scratch, but you've been doing you don't at all. Let's just start with the color of the house, and then we'll sort of move over to the solar side of things and the insulation properties. The color of your house helps.
Yeah, well, it's pale. It's a pale color, a color that reflects sunlight. And here in the Mediterranean climate of Southern California, that's a big plus. You know, it gets to be, in Fahrenheit, it gets to be well over 100 degrees in the summertime up here. I live like totally in the valley. That's like where I live.
Right.
And so like it gets really hot in the summertime. Anyway, so you want to keep the house cool that way. The other big thing for those of you, your listeners, your viewers, who for some reason do not read the journal every Friday.
Who are those?
There's a picture of my house where you see this big tree, a thing we call a camphor tree. In the spring, it smells like Vicks Vapor Rub. Anyway, it provides a lot of shade.
A lot of shade there.
That's a huge thing.
And coming from the exterior, you also, the sort of thermal envelope of your home, if you will, the shell of it, you've been working on that, sort of beefing up the insulation using everything from denim insulation to your windows. You're having insulated windows. Tell us about what you've done there.
So if those of you aren't familiar with denim insulation, a couple of companies have found a way to make the scraps from the blue jean factories into insulation that works better in general than fiberglass insulation. It doesn't have the formaldehyde, and it's treated with a phosphate, the kind of a soap that rats and so on do not eat. And it doesn't burn. In fact, fiberglass insulation will melt. I've done this demonstration many times, will melt under a torch, and this blue jean stuff does not. But all that will not burn, rather. That aside, that's just modern insulation that's a good use of recycled or recovered materials. But the big investment, as you mentioned earlier, are the double pane, low emissivity glass windows. These windows in my house cost as much as a small car to put them in every wall and every one of the windows. But you end up with a house that's much warmer in the winter and much cooler in the summer, using much less energy to run the air conditioner, heat pump.
And you're the science guy, Bill. I mean, people, when they go to shop for windows these days, they hear about solar heat gain coefficient, low E windows, the U factor, and they're like, wait, I just want windows. But the truth of the matter is that these coatings, these low E coatings that can be put on the windows can be beneficial no matter where you live, whether you're in a warm climate like you are or in a cold climate, just depending on how they build the windows.
Oh, yeah. And it's so competitive. And I put these windows in going on 3 years ago. In the last 3 years, I think another half dozen companies have emerged that are in the business. You can figure out which ones will provide the best insulation for the money. And the other thing that's very important to me is they have to look good.
Right.
You don't want windows that don't look good.
And
I found them. And I threw money at the problem.
You threw money at them, and hopefully money is coming back into you in the form of energy savings. Now you've got a solar hot water system, a photovoltaic system for your electricity. I want to talk though, before we have to let you go, about your chili peppers. Tell us about these chili pepper pumps.
So I just stumbled on these things. I'm not an expert on this deal, but it's a box about this big and about that thick. You mount it under the sink, and it's an electric pump. And I would say, as an engineer, just looking at it, it looks about the same size motor as you have in an electric drill. And so it pumps water. You turn on the, you press a very small button, very low voltage button. You can't get a shock from it. And it runs a pump so that it pushes hot water from the hot water side of your sink
Over to the
backwards
cold. Yep, and it's
to the cold water side until the hot water shows up.
Yep. All right, Bill, we're gonna have to leave it there. We're running out of time,
Okay.
but there's more from you online on WSJ.com. Bill Nye, the Science Guy. Thanks for
I
being
have
with
3
us.
chili peppers.
And you
Carry
got-
on. Good to
3 chili peppers. Wow, I never even heard of a chili pepper. So, any questions or comments? Bill Nye's pretty popular guy, the science guy. He's a little house in the valley, doing all the stuff that I've been doing on my house and all the stuff that we're doing on this house I'm building now. We'll go through the plans and look at some of the green stuff that's called out in every plan that we have to do. Green building is here to stay, and it's integrated in all of our construction projects now, virtually every single one of them.
Hey, Rodney,
Yes,
I was just gonna say that it seems like other countries have been way ahead of us in some of this. So I'm glad we're catching up.
yeah, I think you're right, Catherine. I think you're right. And we're gonna take a break. And I might have to take a pain pill. I don't know. I hate taking those. But I've got 9 minutes till. Again, come back. We'll take a break till 5 after again. All right. So 11:05, come back. See you then. Enjoy your break. Come back though. Hey, Linda, can you hear me?
I can, yes.
I wonder, when we're reading the book, are you not able to read it too and just type?
No, I can't because it's just, especially when I'm trying to keep up, I am making sure that what I'm writing on my screen is what I'm hearing. And also sometimes you scroll so quickly that I miss some of it because I'm still like a sentence behind, and then you scroll on to the other thing, so I miss the whole entire thing. It's really pretty hard. I mean, if you could let us have access to the book so I could just add some of these words and everything. But I don't know if you can do that, and we only have one more class anyway, so it might
But,
be.
you know, thinking now in retrospect, I probably should have gotten you that book or gotten you. I can't give you access to it. I got access from the publisher.
Yeah, a lot of professors do that. They give me a textbook, and then so I know on the syllabus what we're going through. So then I prep the night before. I get whatever vocabulary that isn't in my dictionary, but what's germane to the jargon in that particular class, and it makes it for me to have to interrupt less because I know what they're saying because I've seen the word once and I've added it to my dictionary.
And now that I know how you work this deal, next time we are together, I promise I'll do more for you. Okay.
Oh, well, I really appreciate it. It just, it's that much more helpful for the student getting, the great class experience.
Yep.
So I really appreciate that, Rodney.
No sweat, Linda. Okay, I'm gonna take my break.
Me too. Thank you. Oh, the recording.
The recording. Hello, everybody. Welcome back. Welcome back to CT 111 Saturday Lab, the second one from the end. We only have one more Saturday together, May 1st. And then you will take your final exam, your 100-question final exam on Wednesday with Jim, which is going to be what? Second, third, fourth, fifth. Yeah.
Actually, Rodney, just to let you know, Jim said that he would open it up on May 2nd. So if people have Cinco de Mayo events, he's going to let us take it early, just to let you know.
That Jim, always thinking about the students. Love it. He's a good guy. So, okay, great. Yeah, and then I'm done next Saturday, and then I teach my last back to work class on Thursday. Then Cindy and I fly to St. Petersburg, Florida on the 7th, the day after my last class. Can't wait, not really. But yeah, well, we get to see, we'll be there for Preston's 4th birthday, and it'll just be some kind of fun. Now, where the heck was I? I was going to tell you a little bit before I jump back in here. Let me show you a couple more videos. You kept hearing about low emissivity, right? Somebody was just talking about it in that video we just watched about low emissivity, AKA also known as low E glass. So very typical these days when we order our windows, we order low E glass. As a matter of fact, you should just order low E glass. Don't even consider not doing low E glass. It doesn't add much to the expense at all. If anything, it might add a little bit, but it takes out 99% of the UVs that pass through your glass. UVs stands for ultraviolet. And ultraviolet is on the light spectrum that does the most damage to things in the physical world. Ultraviolet does the most damage to your skin, does the most damage to wood, to paint, to carpets, it's what makes things go yellow and leaches the color out. It breaks down the fibers and the molecules in everything. Ultraviolet light. So when you have a regular painted glass without a low E coating, you get all the ultraviolet light comes through that glass, and in some cases it's magnified by the glass, and you get it bouncing around your room, and the more sunlight and the more UVs you get, the more problems you have caused by the sunlight, which is color fading and things degrading and deteriorating because of exposure to UV light. So low E glass, great stuff. Really great stuff. Now, these days, we are bound by green building standards and energy standards, period. We cannot pull a permit to do work legally in the county or the city of Santa Barbara without complying to green building standards. And I'm going to show you how much complying there is by taking you to start out with this, but I'm going to show you 3 pages of a plan that I'm building. This is that job I'm building. You've seen, I've taken you there and shown you videos of this job. I'll blow this up so you can see it a little bit better, but there's 3 pages. Now the plan my whole plan is 9 pages plus 4 structural pages, right? 9 pages plus 4 structural. So that's 13 pages. 3 of them are dedicated to energy compliance and green building. Yeah. So that's almost that. So that's about 22% of the documents in this plan are about green building. So let's blow this up, see how big we can make it. It gets kind of blurry, huh? Can't see. Yeah, I can't. Oh, there you go. Okay. So these are the energy compliance documents that have to be submitted with the plan. Let's see if we can make this even more. Let's give it a chance to focus. Come on, focus. I don't know that it'll get any sharper, but it's oh, there we go. Certificate of compliance for, there's our project name, but it's all Title 24. Title 24 deals with handicap requirements, seismic requirements, and energy and compliance and conservation. All that stuff is under this Title 24. So there's Title 24 compliance sheets have to be a part of the plans. So they talk about building envelope information, required special features. I know you're having trouble reading this because I'm having trouble reading it too. Let's see if I can get to, yeah, so I'll look at the plan myself right here. Yeah, energy compliance documents. They're talking about certificates of compliance for windows. Okay, so I got this in front of me so I can actually read it, but just to let you know what all this stuff, and it's all germane to this property. Some of it's boilerplate. That means they can just, you know, it's the same stuff for every building, but most of it is specific to this building. For instance, there's general information, right? General information, this is really small. It gives us the address, building type, the project scope, the number of bedrooms, gives us all the specs on the building. This part here, that part of this sheet here. And then we go down to certificate of compliance for the windows. So every window in the house right here, and every door, exterior door, and windows, by the way, are exterior. You can conceivably have a window on the interior, but there are generally 99% of the time for exterior. Every window is talked about the type of window it is, where it is, north wall, where it orients to, the azimuth. Oh my God, the azimuth. So where it sits on the compass rose from facing north. Unbelievable. It tells us the area of it, the U factor of it, the U factor source, whether it has a bug screen. It just tells us all this stuff that it has to have on every window and every door, and it has to comply, and it has to be on here. And those are specific to the job. It's not boilerplate. So down below it, this one here, that has to do with pipe insulation. So the drainage, heating, waste systems, pipe insulation not required is what it tells me. You know, the FAU, heating and cooling system, it tells me what? Not a whole lot. It talks about the walls over here. This one talks about the walls and what insulation, walls and ceilings, etc., and how thick, what the R value of the insulation needs to be. For instance, the cathedral ceilings, which we do have some cathedral ceilings, which are vaulted ceilings that don't have a dropped ceiling at an 8-foot plate height, that they vault and show the roof. We have that in the main room in Mangones, and we have it in the bedroom. They tell us what we have to have. We have to have R30 in those ceilings. And if we can't get it, in the size of the rafters, like we in the living room, because we're stuck with 2x4 rafters, it's part of the site built truss system, TRUSS. Then we had to go with rigid insulation to get that R30. We had to go with a 3.5-inch rigid. So we had to build a whole new, basically, roof on top of a roof, a 2x4 grid, 3.5-inch tall grid, to receive the 4x8 panels of 3.5-inch thick rigid insulation to get us the R30. So we had to do that. And it was all on here, what we have to conform to. And then if we go to let's see. We go to, I think it's 8 and 9. Yeah. Okay, here we start with our Title 24. Well, that started Title 24. And then we get into more Title 24 stuff. This is, interestingly enough, called out as the California Green Building Standards Code. This is sheet 2. The first sheet was the one that we went over just a minute ago. Let's see if we can get this so we can see it. Okay, it talks about all kinds of things. A big thing it talks about is the allowable VOCs. So what does VOC mean again? Volatile, where the heck is
It's
it?
volatile organic compounds.
Thank you. Oh, dang, I can't believe I just got a block because I only ever refer to it as VOC. So the volatile organic compounds, which off gas, they're known, and all these things, we have to be, we could get called on it. Our building inspector could say, hey, your primer, your architectural primer, your paint, your non-porous paint is over 250 VOC right on the can. You can't use it. So we got to be careful. There's so much information that we have to know and know about and stay away from. And, this tells us the VOC limits on, I told you, carpets are big, they're big VOC emitters, some carpets, adhesives for carpets and pad adhesives, PVC welding stuff for welding plastic pipes. It tells us pretty interesting things here. I was just reading it myself about, these are formaldehyde limits in plywood and veneer cores, and all this stuff is in your SDS sheets, your safety data sheets. On every material that you can buy is going to have a safety data sheet. If it's got VOCs, it's going to have a safety data sheet. It's going to tell you about the VOC and how much VOCs there are, and also other things that you need to know to keep you safe. Carpet cushions talks about, okay, so this is pretty interesting. This interior moisture control. This first subheading is about concrete slab foundations, and it talks about a capillary break. Concrete's porous. It has capillaries, it has cells. So that means it will not only take water, but it will wick water. It will carry water places when it gets saturated. So you want to have a capillary break. And a capillary break is done by a vapor barrier. And a vapor barrier is just 6 mil visqueen. There are other vapor barriers, but that's the one that we most commonly use, and it works just as advertised. It is a vapor barrier. So right here, a 4-inch thick base of 1/2-inch clean aggregate, okay, blah, 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 slab design, concrete mix, bleeding, shrinking, shall be used, capillary break, god dang it. So the capillary break is with and then a vapor barrier, right? So the base that you're putting the concrete on has to have a vapor barrier in direct contact with the concrete. Talks about vapor barriers. Then we get into indoor air quality. It tells you that you have to have Energy Star compliant ducting fans, and they have to be ducted to terminate to the exterior of the building. They're required in bathrooms and they're required in kitchens. Talks about environmental comfort and heating and air conditioning systems. It covers all kinds of stuff. Hold on for me 1 second, everybody. Hey, I can't talk to you right now. I'm teaching the class, so I'm done right around noon, and I'll call you back on this number. Okay, guys. See you. Bye. All right, would you guys remember? I had a feeling I said, just somebody remind me. Did I start recording again? By the way, did anybody remember? If I did, I think I did.
You did.
Okay, good. And then will somebody help me remember to call this guy back when we're done? See, right before we end, somebody chime in and say, hey, Rodney, remember you said you'd call that guy back from Boynton Beach, Florida? I'm just going to put his name in here, so I'm going to remember. Sorry about this. I've got guests. There he is. Okay, just got to call him back when we're done. Now let's go on to, we have to have documentation to prove all this stuff. We have to have some special inspections when required. We didn't have to have her special inspector, I don't think. But we have to have inspections towards the end that have to do with our lighting and our ventilation. And I'll have to get those together before I can get us a final. In the meantime, let's go to page 9. Oops. Page 9, download. Okay. The second, or rather the third page of our Title 24 are required Title 24 sheets that we have to have on the permitted set of plans and the measures, the mandatory measures that we've got to follow to comply with the green building standards in California, and they're strict. So we are building green now. We don't have any choice. It's been thrust upon us, and I don't mind it because it's a good idea. And there's lots of components to green building, lots and lots of components. I'm not going to cover every single one of them with you, but I want to hit the high points, like planning and design, right? Site development, which we talked about. You got to have electric vehicle chargers now, by the way. So new construction and this remodel that we're doing, it's required that you have an EVI charging station for new construction. They're anticipating that we are going to have electric vehicles in the very, very near future. So we're required to put in charging stations for electric vehicles. And we have done it on the Mangones. It's just all kinds of, stuff about your EV charging, electric vehicle charging, faucets. We've got to have lavatory faucets that have a maximum flow rate of X. They can't exceed 1.2 gallons per minute at 60 PSI, which is normal house pressure. Lavatory faucets in common, okay, public use, that's not us. We don't really have any metering faucets. We're not installing metering faucets in residential buildings. Kitchen faucets, again, 1.8 gallons per minute at 60 PSI. And those, anything you're buying that's UL rated in Santa Barbara right now, they're going to have those ratings. So you're not going to have to worry about that too much. Your shower heads, all of that stuff. They're going to have flow restrictors in them. If you want more water pressure out of your shower head, take it apart and pull out the flow restrictor, but don't tell anybody I tell you that. Outdoor water use, what you can use. I don't think this covers gray water systems, but maybe it does. Let's see. Construction waste, it covers waste management for us, how we can dispose it and recycle it. And it requires us to reuse a minimum of 65%, right? 65% of our construction waste has to be sorted and it has to be reused. But guess what? That's non-hazardous. We don't have to do that because we have Marburg, and Marburg does it for us. So we pay for that, but we get something from it. That's for sure. Waste management is big. And then building, we have to have a maintenance and operation manual when we're done. We have to provide them with a disc or manual that tells them all this stuff, how to operate their equipment, and on and on and on. We have to conform to environmental quality as far as composite wood products. They can only be certain things. And by the way, backing up to just jumping back into green in the textbook, I made a note to myself that the framing members like LVL, which are laminated veneer lumber, and TGIs, which are truss joists, I-beams, and micro lams and glue lams, which are framing structural members that are made from small pieces of wood that are more like the waste from wood milling. wood chips, sawdust, and pieces of wood go in to make these products, and they're way more energy efficient because they use recycled materials and they use way more of the log. So any questions about Title 24? Anybody, any questions about Title 24, about those sheets that I showed you? Now you're going to see those Title 24 energy compliant sheets on every single plan. Every plan. The cover sheet on a set of plans that's going to be permittable is going to have something on it. It says code compliance requirements. This project shall comply with residential code, plumbing code, electrical, mechanical code, fire code, energy standards, green building, and grading ordinance. So all those things should be on your sheet index. They're going to be on every plan. Now, that's not to say that every job that you do or gets done by you, or you have done, or is done on your house, or you do, pardon me for yawning, is going to be permitted. That's not necessarily going to be true. If you do work that's cost less than $600, you don't need a permit. There's all kinds of things that you can do that don't need permits, and and there's a lot of things that do need permits that people don't get permits for. But when you are doing anything major to your house, changing the way it looks on the outside, adding rooms, adding square foot, changing the water heater, replacing the roof, you're going to need a permit, and you're going to, except for the water heater, the roof things, those are incidentals, over-the-counter permits. But the larger things that you do to your house, like add on to your house, gut and remodel your house, add windows to your house, you should get a permit. If you don't get a permit, there's some things that can happen to you that are unpleasant. They aren't necessarily going to happen, but they can happen. Your job can be shut down if a building inspector drives by, or your neighbor calls and says, hey, I don't see a green card in the window that says they have a building permit. I think they're doing this illegally, and they come and look at the work you're doing, and they decide that you're doing work that should have a building permit. Then they can shut your job down, red tag your job, and say no more work can happen here. You don't want that to happen. So get permits whenever possible, and where required. So let's go to
Rodney,
yes.
how many times have your jobs have been red tagged? If any?
I think I'm trying to think of, I think twice in the literally hundreds of jobs that I've done, and not all of them permitted, but I would say the preponderance of the jobs I've done have been permitted. I've been red tagged twice. You know, once we had to go back and get a plan. I can't even remember the circumstances, but the one I do remember was I was red tagged for 24 hours. They red tagged the Santa Barbara Athletic Club that I was remodeling their lobby cabinetry, and it was mostly cabinetry in their lobby. It was cosmetic, and it was like for like, and it was fixing some electrical. And one of the senior building inspectors was working out there, saw the work, jammed us on it, red tagged the job. I went in and saw George Estrella, the building inspector, that day, and met with him. And I can't remember the guy that did the red tag, and just explained the job to them, that we were doing cabinetry, and that the electrical that he saw was just fixing a surface mounted quad box. And they said, fine. They tore up the thing, and they said, you can do it. You can do it without a permit. And that could have gone either way. It went my way and my customer's way, because it would have stopped the job completely. And it would have been a real drag for the Santa Barbara Athletic Club. And we would have had to go back through a whole bunch of hoops, which would have taken a fair amount of time to get this thing back on track. So it saved them a lot of agony, saved me a lot of agony and heartbreak, and everybody money. But because I was willing to go communicate, and I was also I also knew who to go talk to. You know what I mean? Like you can go down to the building department and start yelling at people at the counter and, you know, banging your fists and stamping your feet or cajoling or wheedling or trying to convince people, but you've got to talk to the right people, right? Most of the people in the building department, there's nothing they can do about it. So I knew who I could talk to. I knew I went right to the source, the head guy at the time, George Estrella, and he made it happen. And it could have gone either way. It could have not made it happen, you know? Communication, open, honest, kind, respectful communication between human beings solves all problems, has the potential to solve all problems with human beings. That's my personal philosophy, and I live by it. And when I don't, I usually pay, right? Usually pay. When I'm not willing to communicate, get to the nitty gritty about problems and get them flat with people that I'm having problems with, doesn't work out. But generally it works out because I am willing to communicate, man. If nothing else, I'm willing to communicate. So let's see where we're going from here. Where are we going from here? We're gonna go, I'm not going there. I'm gonna go here. Okay. I think we looked at resource efficiency, didn't we? No, we didn't. Okay, let's look at this.
When world leaders adopted the 2030 Agenda for Sustainable Development, they recognized that social and economic development depends on the sustainable management of our planet's natural resources. They also identified resource efficiency as a prominent means to ensure the sustainable management of natural resources. What is resource efficiency about? Resource efficiency refers to the ability to create more goods and services, more wealth and human well-being with less input of natural resources. How does our region, the Asia Pacific, fare in terms of resource use and efficiency? The region accounts for more than 50% of global material resource consumption, but produces only about 32% of world.
Okay. That's pretty dang telling. I want to go back. She's talking about.
The region accounts for.
Yeah, Asia Pacific, right? So I think that includes us too, because we touched on the Pacific, our coast. They're saying that we use almost half. We consume almost half of the world's material resources, and yet we only produce
more than 50% of global material resource consumption, but produces only about 32% of world economic output, making it one of the most resource-intensive regions in the world. It takes approximately double the quantity of material resources as input to produce each dollar of GDP in the region when compared to the rest of the world.
Wow.
Hence, there is a huge opportunity to improve resource efficiency in the region. But why do we need to improve resource efficiency in Asia Pacific?
Okay, so I guess it doesn't touch on California. We're talking just Asia. All right. Okay. That's good to know.
ESCAP's analytical work shows that there is a strong relationship between resource efficiency gains and progress made in Human Development Index, access to water and electricity within the region. Without significant improvements in resource efficiency, achieving global climate targets envisaged by the Paris Agreement will be difficult and substantially more costly. So how do we achieve improved resource efficiency? We need macro-level and sectoral policy interventions. Macro-level policy pathways involve integrating resource efficiency targets within national development agendas and creating an enabling regulatory and fiscal environment to incentivize resource-efficient economic development. Taxation and fiscal measures such as fossil fuel subsidy reforms in combination with innovative financing mechanisms such as green bonds can accelerate transition to resource efficiency. Countries also need to evaluate resource efficiency implications of trade portfolios and position in global value chains. At the sector level, resource efficiency targets need to be mainstreamed. Scientific, technological, and innovation capacities need to be channeled towards resource efficiency. Effective waste management practices and promoting lifestyle changes will allow recovery of valuable resources. These measures need to be paired with strengthened statistical capacities to accurately account resource usage and their impacts. We can achieve more with collaboration. SCAP can play a key role to increase the capacity of governments, conduct policy-relevant research, provide platforms for mutual learning, and promote regional collaboration in improving resource efficiency. Let us work together to make the Asia-Pacific region a torchbearer of resource efficiency.
Good one. So, without politicizing this, which I don't want to do, and forgive me if I come across as politicizing it, but I'm a human being, and I am convinced that all of you are as well. And as well as everybody else I know, and everybody else I don't know. So first and foremost, I consider myself a human being and a member of the population of humans on the planet Earth. Before I'm an American, before I'm a Caucasian, before I'm a Christian or a Buddhist or a Jain or a Hindu, before any of that stuff, I'm a human, and I want all of us humans to make it on this planet. And I'm one of those people that believes that if we don't wake up, and I think we are waking up to what is happening with the planet, that we're gonna endanger all the humans on the planet if we don't do something about how we use energy and the planet's resources. We're using resources at an alarming rate, and we're pretty hip to that. We're all pretty hip to that right now. Not everybody, but if you look at things like, just look at something as simple and as easy to see as wood. Houses are framed in wood for the most part. Now, that's not to say they're not made in masonry, steel, hay, skins, wattle and daub. There is a variety of ways to make houses, but generally around here we frame in wood, and wood is a renewable resource. And companies like Weyerhaeuser and Georgia Pacific realized that decades ago, and they started planting trees that could be harvested in 10 years. So from seedling to a viable piece of lumber in 10 years. Bamboo even faster. You can do 5 years. You can do bamboo. So renewable resources that we can keep having and keep using. Someone told me the other day, and I don't know if this is true, I didn't have a chance to check on it, but that some of the precious metals, rare earth type things that are used in our high-tech construction computers, there's a finite amount of them, and that in 2 decades they'll be gone, and we won't have them to use in the computers we know now. Now, I don't know if that's true, but let's just say for purposes of argument that it is true. The one saving grace is technology is moving at such a rate. We are making such strides in the areas of technology that I do believe that we'll do workarounds for all that stuff. And then we will find ways to make things with what we have and not use up all the planet's resources. And And I don't know how you feel about climate change. Some, whether they believe in it or not, I firmly believe that we are undergoing climate change as a planet. I'm going to have a lecture next Saturday. I'm going to have a man or a woman, I can't remember who, from this 3C REN. I think they're going to talk to us about climate change. I think it might be electrification and it might be ventilation, but I'm pretty sure I've got them slotted for climate change. So we're going to have somebody come from this outfit in Ventura that provides energy compliance consulting to the building trades, especially architects and engineers, but everybody. Then they're going to talk to us about, hopefully they're going to talk to this class about climate change and what we can do about it, because we're all involved in it. This is all us. Green building is a natural evolution of the building trades to a more green and efficient way of building. So it just makes sense, right? We use less resources. The resources we do use work better, last longer. The quality of our lives is improved, and with using less. And you know, just, and it's kind of everyday stuff, but it's, for me, it's in some respects, I'm consumed by it. And I'm consumed by it right now because on my set of plans, so this is the title page. This is the title page of the place I'm building right now. It has a lot of information on it. A ton of information on it. But one of the pieces of information that I'm dealing with right now on a minute by minute basis is right here. I'm gonna make it a little bit bigger. And so everything on this plan is important because it's part of the permit. It's part of what I have to do. I have to meet conditions. And if it's on the plans and it's been approved by the County of Santa Barbara, then I've got to have it done. And so the thing I'm dealing with right now is permeable, right? Permeable. You see it in 3 places right there. Permeable. Permeable paving. Permeable means water can get through it. Oh, what the heck? Permeable means that water can get through it. Now, regular concrete driveway, a regular asphalt driveway, the driveway that's there now, the interlocking pavers are not permeable. It's on a compacted road base. Chip seal's not permeable. Most of the driveways you think about are not permeable. My owner wants a gravel driveway. She does not want interlocking pavers, which there are permeable interlocking pavers. It has a lot to do with the base that your driveway goes on. So there are ways to do permeable gravel driveways. Unfortunately for me, or so far, I can't find any handouts by the city of Santa Barbara, or the county of Santa Barbara, rather, that's who I'm working with, that specify what they consider to be permeable or what's acceptable as permeable for a gravel driveway. So I think I'm going to be reinventing this wheel. I think I'm going to come up with the specs to do a permeable driveway. And now the good news for me in this permeable driveway is that one of the really big problems that I had in my project is that the street is higher than most of the property. So getting the runoff water out to the street, to daylight onto the street and to run off and go somewhere down a storm drain has been a real problem. So I was going to have to do or dream up, basically invent a big old collection box with a drain attached and a sump pump somewhere in that driveway. But as it come to find out, meeting with Kurt Kopis of Challenge Asphalt yesterday, who gave me an idea of some specifications for an acceptable permeable gravel driveway, is that whole driveway, which at this is what? It's probably going to be, it's probably 20 by, it's at least 1,000 square feet, at least 1,000 square feet. That's going to be all collection. Because if I do it right and make it all permeable, then the water that runs to that driveway will permeate the soil. It will not run off. It will go down and perk down and give the water back to the water table and recharge the aquifer, because that's what we want to do. We want to take the runoff. Water efficiency is huge. We want to take the runoff.
In the United States,
we want to take the runoff from our house, from the roof runoff, from any hard surfaces, any runoff on our property. We want to, rather than put it in the storm drains and have it leave our property, we would rather put it back in the aquifer. So let's see what this video has to say.
we're facing a national water shortage. Government-backed research shows that in a little over 50 years, half of the freshwater basins may not meet our demands. For this story, I'm in my home state of Florida. Here, the water crisis is real and demanding positive action.
This is Silver Springs. Almost half of Florida's fresh water comes from aquifers like this, natural underground reservoirs that are topped up by rainfall.
But earlier this year, wet season rainfall in the south of the state fell by 45%. And the pressure is mounting as Florida's population grows by around 300,000 people a year. Our water situation is unsustainable. I've come to Naples Botanical Garden, a leader in best practices for conserving water and horticulture.
If I understand correctly, up to half of Florida's residential water goes back into irrigating our gardens. What can we do to make that more efficient?
We have about 6 months out of the year where we have an abundance of rainfall and 6 months where we have drought conditions. Being a botanical garden, we really focus on selecting plants that can take those cycles of drought. If you do that, we can really cut down on irrigation. That's really climate-friendly gardening. We're working with nature.
Is there something we can do at home to collect our water, protect our water, and reuse it?
Yeah, so in my own home, I have rain barrels. When it rains, we collect water, and I use that water to water my garden throughout the dry months of the year. Quite often, we think of the environment as something that's out there. We think of the Everglades, but really the things that we do in our own homes, that's a part of the environment. Our backyard is part of the environment.
But it's not just outside where we can make a difference. On average, American families use more than 300 gallons of water every day, and a lot of that is being wasted. I'd love to see how my family can save water at home. From dripping toilets to faulty faucets, leaks in our homes can lose nearly 1 trillion gallons of water every year.
Just replacing a 50-cent washer on a faucet can save up to 3,000 gallons of water per year.
And many of us still rinse our dirty dishes under a running faucet before loading them into the dishwasher.
This is a huge waste of water because you actually need the dishes to be dirty and the enzymes in the detergent latch onto food particles to work effectively.
We have less water than we.
Yeah, so put your dishwasher wants your dishes to be dirty. Okay? I don't care what anybody tells you. Your dishwasher wants your dishes to be dirty. I've had this argument 50 million times with my wife.
But the minute we realize that every drop is valuable, we begin to change our behavior for the better.
Whether that's creating a climate-friendly garden, fixing that leaky faucet, or just not pre-rinsing our dishes.
It's these little water-saving measures that can be done by me in the home and all of us across America that can help make a huge difference for our future water security.
And how many people let their faucets run when they're brushing their teeth? Yeah, it's like I did it for so many years Now it's ingrained. I don't do it, but man, I did that for my whole life. I let the water run while I brush my teeth, which is just ridiculous. And now it's really bad because I now have this smart toothbrush, right? It gives me an unsmiling face if I don't brush for 2 minutes. It gives me a happy face if I brush for 2 minutes. So it's got me trained. I don't want the unhappy face. I'm sorry, Linda, it appears there is no closed captioning on this one. It's only 2 minutes.
This oceanside Verbo is about to become the backdrop for an unforgettable vacation.
We spend 90% of our time indoors. The standard of the buildings where we live, learn, work, and
Hey,
play
Rodney, I think there is
is
no
not only our health, but the quality of our lives. Buildings are responsible for 41% of
Rodney, can you hear me? Linda? Excuse me?
Oh, sorry, Linda.
Yeah, I just said, I think I see closed captioning on this one. Thank you.
My bad. I never say my bad. I'm never going to say that again either.
of all potable water usage, and 73% of electricity used in the U.S. LEED has transformed the way we think about how buildings and communities are designed, constructed, maintained. LEED projects are responsible for diverting over 80 million tons of waste from landfills, a number that is expected to grow to 540 million tons of waste diversion by 2030, all while conserving water and energy, reducing environmental impact, conserving resources, promoting energy independence, and saving money is at the core of what LEED is all about. Whether it's renovating your existing home or office building, or designing a building from scratch, LEED helps builders create and construct with people in mind. LEED matters because where we spend our time matters. Daylight, good acoustics, and healthy materials matter. Fresh, clean air and water matter. Design that encourages movement matters. LEED creates healthy spaces, keeping the bad out and bringing the good in. cities in all 50 states and more than 150 countries are already saving money with the help of LEED. This could mean freeing up valuable resources that can be used to create new jobs, expand operations, and invest in emerging technologies. LEED is the most widely used green building rating system, with over 1.85 million square feet of real estate certified every day. There is no project too big or too small, from retrofits to new construction, to neighborhoods with single or multifamily homes. LEED helps leaders make the right choices for their communities. Better buildings are our legacy.
Cool. So back to the book. We didn't get through the book, nor are we. It's a very short chapter, so we only stopped about 1, 2, 3, 4, 5 or 6 pages away. So you're all expected to read the book. There's only 10 review questions. James is going to probably have those review questions, some of those questions for you in your test. He and I will go over the tests together, actually your final. So I'll be throwing some stuff in. You can guarantee the stuff that we talked about today. You'll have some questions on there. And yeah, finish reading that chapter, please, if you haven't, and go over the review questions. We covered a lot of them. And like number 3 here is windows that face blank will allow the greatest amount of the sun's energy to enter the house. What's the answer?
South.
Thank you. In this hemisphere. What if you're in Australia?
North.
There's Australians. They have it backwards. What's up with the shrimp on the Barbie people? But yeah, my friend Peter is building a new house. What did I want to tell you? We're all affected by this. This is not just the building trades. This is how we operate as human beings. We are all should, and I kind of hate to use the word should. I don't mean to be shooting on you, but we should be thinking about conserving water. We should be thinking about conserving energy. I don't light empty rooms. I just don't do it. I just can't do it. I live with somebody that doesn't mind lighting empty rooms because she likes that warm feeling in a house. Personally, when I'm there by myself, I am lit up in the room I'm using. And if I'm watching TV, I don't have any lights on. So I fix leaks immediately. I can't stand wasting water. And, just those little things. I'm going to get me an electric car. I'm going to get me a Bolt. My IT guys got one, and my friend Peter Kornbluth, whom I just talked to about the skips panels, I got his, I called him up and I asked him, hey, what does skips mean, right? So we talked a little bit about what we're talking about here, and Peter told me he just got a Bolt. So these Bolts are a GM car. He got even more back. So my IT guy got a Bolt. He leased it for 3 years. He paid $4,000 down. He got back $3,000 of the 4. He got back 3,000 rebates. So he was $1,000 out of pocket.
Buddy and Bandit.
I'm sorry. His payments are cheap. They're less than $200 a month. He gets 260 miles out of a charge, and he's got no maintenance. I mean, the maintenance is the tire rotation. There's no oil changes. You're not polluting the air. You're not using fossil fuels. You're still, using rubber tires and the stuff that goes in to make the thing, but electric cars, it's happening, man. Check out the Bolt. I'm pretty sure I'm going to get one. As much as I like my Lexus hybrid, I think I'm going to get me a Bolt. As soon as Cindy's Prius does anything that I don't like, I'm getting a Bolt. So it's now 1 minute after 12. Does anybody have any comments or questions they'd like to ask me before we say goodbye this second to the last? I'm starting to get choked up and sad about not seeing y'all next week, right? If we had class here, we'd have a party and we'd have pizza and fizzy water without the sugar, and we'd have a great old time, wouldn't we? I don't know what that is. So, but we can't do that. We're doing this online. So, but please all come, and it's going to be great to see you for our last class. And I don't know what we'll do, what our topics are going to be. Jim and I will figure that out. But hopefully, we'll do something that is fun too. And I hope this was fun for you, because this was really fun for me. I was thinking, green building. What do I know about green building? But the truth is I know a fair amount about green building. I have been doing green building for decades. And now green building is such a part of what we do, especially here in Santa Barbara, that it's inculcated and a part of how we build. And it's a good thing, and it's just going to get better. So think about it, okay? And you too, Dennis.
Will do.
Thanks for coming. You guys have a fantastic week. Have a fantastic weekend. We'll see you all next Saturday.
Okay,
Thank
thanks,
you, Rodney.
Catherine,
Bye.
good to see you. All of you.
Bye.
Hugo.
Don't forget to call Florida guy.
All right. Later.